Lesson 5.3, Transformations and Symmetry of Polynomial Functions continues. In this video, we will graph and write a specific equation for a function given its equation in terms of power functions. Alright, use each basic power function shown to complete the table of values and sketch a of x on the coordinate plane. Then write a specific equation for a of x. Alright, so first thing we're going to do is just fill in the table. So g of x is x squared. So negative 2 squared, positive 4. Negative 1 squared, positive 1. 0 squared is 0. 1 squared is 1, 2 squared is 4. So we're just going to go through and complete this table. F of x is just x. So negative 2 is negative 2, negative 1 is negative 1, 0 is 0, 1 is 1, 2 is 2. Okay, so we're going to evaluate each of those separately. A of x says that we have g of x plus 3 times f of x. So on this here, we have g of x, which was 4, plus 3 times negative 2. Well, negative 2 times 3 is negative 6, plus 4 is negative 2. Okay, we're going to do that with each of these. 1 plus 3 times negative 1. Well, negative 3 times 1 is, 3 times 1 is negative 3, plus 1 is also negative 2. And then we're going to do the same thing with 0. 0 plus 3 times 0. Well, 0 times 3 is 0, plus 0 is 0, so 0 is 0. Then we have 1 plus 3 times 1, and 3 times 1 is 3, plus 1 is 4. And then the last one, we have 4 plus 3 times 2, and 3 times 2 is 6, plus 4 is 10. So each of these creates a coordinate. The x is in the first column, so negative 2. The y will be the last thing we found, also negative 2. The next ordered pair would be at negative 1, negative 2, and then 0, 0, and then 1, 4, and 2, 10. And we're going to plot each of these on the graph, and then we're going to draw a line to connect them. So first point is at negative 2, negative 2, which is here. The next point is at negative 1, negative 2, which is here. Okay. Then we have a point at 0, 0 up here, a point at 1, 4, and then 2, 10. 2, 10. Sometimes when doing these, the points don't fit on the graph, and that's okay. We don't have to worry about it. We'll just do what we can. Alright, so we're going to draw a line connecting through these. We do know that this is squared as its degree, which means that it's even. So in behavior means they start and end the same. And A is positive because there is nothing written there. So A is positive. So that means that they begin and end positive, or at least it ends positive. And if it ends positive and they're the same, they begin and end in the same place. So what we have here is that we're starting at the top, coming down through our point. Not very symmetric. They should have been out more. Something more like that. So that's what it should look like. Okay, and it should be a parabola because g of x is x squared, so we know it's a squared function. As for our equation, well, all we're going to do is stick the power functions back in. So a of x is equal to x squared plus 3x, and that's our specific function. We don't have to figure out the graph in order to do that. We can just look at the equation and substitute. All right. What I'd like you to do now is try number 17 on your own. Pause the video right now, and then unpause when you're ready to check your answer. Okay, so hopefully this is what you got for your answer. J of x is x to the fourth, so we get 16, 1, 0, 1, 16. G of x, like in the last problem, is x squared, so it's 4, 1, 0, 1, 4. We plug the stuff in according to the equation. We get 4, negative 0.5, 0, negative 0.5 again, and 4. And then we make ordered pairs out of both the x and the result. Looking at in behavior, it's an x to the fourth, so it's even. Again, it starts and ends the same. A is positive, so that means it ends positive, which means it also starts positive. And then I plotted my points and I drew my graph. Looks something like what you see here. And then I made the equation by putting the x to the fourth in for j of x and the x squared in for g of x. And that's how we do use basic power functions to graph and then write a specific equation.